Hey YouTube, Tim Unkert here. In this video, I want to talk about two special right triangles, and those are the 45-45-90 right triangle and the 30-60-90 right triangle. And what those numbers refer to are the degrees of the angles in the triangle. And I'm going to specifically talk about the ratios of the sides. So let's talk about the 45-45-90 first. So I'm going to draw one of those. Okay, so we've got our 45-45-90 here. Let's say this angle is 45 degrees, and this angle is 45 degrees. And let's say this side is just a length of 1, and if the side opposite 45 degrees is a length of 1, the side opposite this 45 degrees should also be 1. So if we want to use the Pythagorean theorem, we can figure out the length of the hypotenuse, and that's going to be basically 1 squared plus 1 squared equals our c squared, which is going to be, c is going to be our hypotenuse, right? So 1 squared is 1, so we have 1 plus 1 equals c squared. So 1 plus 1 is 2 equals c squared. To figure out what c is, we'll have to take the square root of c squared, and we have to do that to both sides. So we get c is equal to the square root of 2, or 1 times the square root of 2. That's another way we can think about this. Now we can generalize this and take this to any side length for, not just 1 here. So we could rewrite this and just, let's say if this is, this side is x here, then this side would be x as well. Then the long side here would be x times the square root of 2. Okay, so we can use that to figure out different ratios of the sides, and we'll do that in problems in a moment. Now let's talk about the 30-60-90. Okay, so I'm going to draw one of those right down here. So we'll do our 30-60-90. Pretend that's drawn with an actual 90-degree angle there. So this would be our 30-degree angle. This is our 60-degree angle. So if the side opposite 30 degrees is x, the hypotenuse is going to be twice that, and I'll speak about why that is in a moment. And the side opposite 60 degrees is going to be x times the square root of 3. Okay, so let's think about why that is. Well, the sine of 30 degrees, if you plug that into a calculator, that's going to be 0.5, or 1/2. So it does make sense that if we have x divided by 2x, we get our 1/2. The approximation for the sine of 60 degrees, if you plug it into a calculator, is going to be 0.866. That's actually equal to, not approximated, it's the square root of 3 divided by 2. And we can see that, if we had x square roots of 3, the side opposite over the hypotenuse, over 2x, the x's will cancel, and we'll get the square root of 3 over 2. That does make sense. We can also think about this in terms of doing the Pythagorean theorem. Does this work out? So we have x squared plus x times the square root of 3 squared. Is that going to equal 2x squared? Let's do it out and see. Okay, so we get x squared. When we square this, we get 3x squared. And when we square this, we get 4x squared. So does x squared plus 3x squared equal 4x squared? Well, yes, it does. Okay. Now, smarter people than myself, they figured out the ratios of the sides and all that. But these are the ratios that we're going to use for the problems, and we're going to stick with that for this video. Maybe in a later video, I'll delve more into this if it's interesting. If it is interesting, leave a comment in the comments below. Okay, so now let's go to some problems with these ratios here. So let's look at this first one. So we have the side opposite a 45-degree angle in a right triangle measures 3 centimeters. How long is the hypotenuse of the triangle? So let's first draw this out. So we have our 45, 45, 90. And the side opposite The side opposite the 45-degree angle is 3 centimeters. So both these sides are 3 centimeters. Well, if you remember in the intro, I said that you take the length of this side and multiply it by the square root of 2. So the hypotenuse in this one is just going to be 3 square root of 2 centimeters. Okay, so 3 square root of 2 centimeters. All right, let's go down and look at another problem. So the side opposite a 30-degree angle in a right triangle measures 10 inches. Okay, let's draw this out first. So we have our 30-degree angle. The side opposite that measures 10 inches. So if we don't want to think about the hypotenuse, we know that's 20 inches, but that's not what the question is asking. It's asking us, well, what's the side opposite the 60-degree angle? So this side at the bottom here. Well, if you remember from the ratios, if we take this side length and multiply it by the square root of 3, so 10 square root of 3 inches will be the side opposite the 60-degree angle. So that'll be our solution in that case. Okay, let's take a look at another type of these problems. So the hypotenuse of a right triangle with angles of 45, 45, and 90 degrees has a hypotenuse with a length of 2 feet. What are the lengths of the other sides? All right, let's draw this out. So we've got our 45, 45, 90. Now we're given the hypotenuse length, so that's 2 feet. Okay. Well, this is square root of 2 times as much as this side. So if I divide 2 by the square root of 2, I'll get these side lengths. But of course, we should rationalize the denominator, meaning we don't want to have the square root in the denominator. So to do that, we'll multiply by the square root of 2 over the square root of 2, which is like multiplying by 1. And on the top, we'll get 2 square roots of 2 over square root of 2 times the square root of 2 is just 2. So we have 2 square roots of 2 over 2. Now, if we want to simplify this, we can cross these out, and we can just leave the side, each of these sides opposite the 45-degree angle is going to be square root of 2, and that's in feet. So square root of 2 feet is going to be our solution here. Okay. Let's look at another one. Okay, so the hypotenuse of a right triangle with angles of 30, 60, and 90 degrees has a side opposite the 60-degree angle that has a measurement of 4 meters. All right, so let's draw this out. So we have our 30, our 60, and our 90. And the side opposite 60 degrees has a measurement of 4 meters. Okay, we want to know the lengths of the other side. So remember, this is the square root of 3 times as much as this side. And once we find this side, we can double it to find this side. So I'm going to do 4 divided by the square root of 3. And again, we'll rationalize the denominator by multiplying by the square root of 3 over the square root of 3. So we'll get 4 square roots of 3 over 3. And that's going to be this side. Now, if we double that, we'll get the hypotenuse. So that's going to be 8 square root of 3 over 3. And what are the units? Well, there are meters. So we want to label it with the correct units here. Probably, I shouldn't be erasing my work, but I just want to make room for the label of the unit. So this is 4 square roots of 3 over 3 meters. This is 8 square roots of 3 over 3 meters. Hopefully this video was helpful to you. If it was, please like and subscribe if you haven't done so already. Also, I'll leave a link to my Teacher Pay Teacher store in the description in case you're a teacher or a parent that wants to check out some of my worksheets. And I'll also leave a link to my website in the description as well. Have a great day and hope to see you in the next one.